Hey everyone, I'm just recording this video on measuring angles in degrees and radians. So this is exercise 14A of our textbook. So we're going back to the start of our notes here for chapter 14. Basically in this section what we introduce is a different unit of measuring angles. So you're probably pretty familiar with measuring angles in degrees, because that's typically how we've measured angles all the way since sort of year 7, I guess. But radians are another unit that we use to measure angles. And the comparison I'd make is that it's a little bit like if you think about distances and how you can talk about distances in kilometers, but you can also have distances in miles. And they're two different ways of measuring the same quantity, but you need to kind of understand how to convert between one and the other, because someone might give you, a distance in miles and you want to know how far that is in kilometers. Similar thing with degrees and radians. So let's introduce this idea of a radian and a little bit about where it comes from. So basically a radian, and this is a complicated idea, but a radian is, if you imagine a circle or part of a circle where you took this section, this length of an arc, and you cut it so that the length of the arc was exactly equal to the radius of the circle. If you do that, then the angle that is formed here at the center of the circle would be 1 radian. That's the really technical definition of it. Now what that means, I guess, is that if this little section is 1 radian, and this radius is 1 unit, then a full circle, if we use our knowledge of the circumference of a full circle has a circumference of 2 times pi times radius, which in this example would be just 2 times pi times 1. So the circumference of this particular circle is actually just 2 pi, and that's a really key idea. Okay, so essentially what we're saying, and there's a little picture of this thing down the bottom here that we're calling a unit circle. Now the definition of a unit circle is its radius is 1. So we consider the full distance around the unit circle, one full revolution of the unit circle, is just its circumference, which is 2 times pi times radius, which is just 2 times pi times 1. So that gives us a really nice conversion between degrees and radians, because we're now saying that a full revolution of this circle, if we talk about it in radians, will be equal to 2 pi, 2 times pi. We also know from our knowledge of degrees that one full revolution is 360 degrees. So we get this key idea that 360 degrees is equivalent to 2 pi radians. And that's really the big idea that you need to understand from this section. So I've actually added this next slide in. This one's not on your notes. It probably should have been. But the key point here is that 2 pi radians is equal to 360 degrees. So here's some really common angle conversions that you can kind of figure out pretty quickly once you know that relationship. And also notice the notation here that's going on. So 360 degrees is equal to 2 pi radians. You can see that small little c is actually often a symbol that's used for radians. Sometimes that gets dropped off when we write an angle in radians, but that technically is a unit that demonstrates that it's a radians angle. Now, if you divide both sides of that equation by 2, you get 180 degrees equals pi radians, and that's a really useful one for making conversions. We can see some other common angles. 90 degrees is equal to pi on 2 radians, which makes sense. It's just half of 180. 45 degrees is equal to pi on 4. Makes sense because 45 degrees is just 1/4 of 180. And 30 degrees is equal to pi radian, or pi on 6 radians. And again, that makes sense because 30 degrees is 1/6 of 180. And we said back up here that 180 is equal to pi. So using this idea of 180 degrees equaling pi radians, we get these kind of two really nice conversions. So anytime you are asked to convert a degrees angle into radians, you can multiply it by pi over 180. And that's just because for each degree, for every 1 degree, there are pi over 180 radians. And when we have to convert the other way, from radians to degrees, we multiply by 180 degrees over pi. We multiply by 180 over pi. And again, that's just because each single 1 radian is equal to 180 over pi degrees. All right, so let's try some examples, and hopefully, as always, that sort of brings things together and helps your understanding a little bit. So example 1, we've got to convert a couple of different angles that are written in degrees, we're going to convert them into radians. So the first one is 120 degrees. Now the work solution will just pop up here in a second, but I'll talk you through it quickly. So we're converting from degrees into radians, and so from 2 slides back, the method is you take the degree measurement and you multiply by pi over 180. Now, as you can see, you can kind of think of this as one fraction multiplied by another, and that just means that we've got to do some cancelling. All right, so we get 120 on the top, we get 180 on the bottom. We can cancel both of those fractions, or both of those values down. You can actually cancel them all the way down to 2/3. And of course, we're left with this pi on top. So 120 degrees is equivalent to 2 pi over 3 radians. And you can see that in this example, that little sort of C has been dropped off. Usually, especially when there's a pi in the answer, it's kind of implied that that's a radians measurement. So that's why often that little small c is left off the answer. For 270 degrees, so this one says to do it using a CAS calculator. So what you can actually do, and it's quite straightforward as long as you get your calculator in the right mode. We want to get an answer in radians here. So down the bottom of your calculator where it says, degrees, or might say GRA or RAD, just flick that into RAD mode, radian mode, and then all you have to do is actually type in 270, and on your keyboard, when you bring up your keyboard, actually it's in Math 1, it's in Trig as well, but in Math 1, you can see down the bottom right, you've got a little degree symbol and a little R, which is actually another symbol for radians. So basically all I'm going to tell the calculator is here's 270 degrees, and I use that degree symbol. But I've got my calculator in radians mode, so all I actually have to do is hit execute, and it'll tell me what the angle is in radians. Now we wanted exact answers here, so I don't want to be in decimal mode. I'm going to change decimal into standard, hit execute again, and we get 3 pi on 2 radians. Okay. Next example. Oops, the answer popped up straight away. That's a bit of a spoiler, isn't it? Whoops. Anyway, that's fine. Next example said to convert the following angles into degrees. So these are angles that are in radians, and we want to write them in degrees. So the conversion, what we do is we multiply, and this is again from a couple of slides back. When you go from radians to degrees, you take the radians angle and you multiply by 180 over pi, and then just cancel it down as far as you possibly can. So what happens here, as you can kind of see from this first line of working, is that we'll have a pi in the numerator, pi in the denominator. They can cancel down. We also have 180 in the numerator and 4 in the denominator. So you can kind of cancel those two. 180 divided by 4 actually equals 45. So what you're left with is just a 3 on top and a multiplied by 45 on top. And everything else on the bottom is actually cancelled down to 1. So we just get 3 times 45, which is 135 degrees. And at least as a rough estimate, that kind of makes sense, right? Because 3 pi on 4 is essentially 3/4 of pi. So this angle had to be 3/4 of 180. So even just as an approximation, we knew that it had to be kind of like close-ish to 180, but less than it. Okay, and then for the second one, we've got 0.8 pi radians, and we're trying to get that into degrees using our CAS. So this is just kind of the reverse process of before. We want our answer to be in degrees now. So let's change that to degrees mode down the bottom. Then we just type in 0.8 pi, and we use this little radians symbol, this little R. Hit execute, and it tells us that's equal to 144 degrees. Next couple are just calculator questions again, so it's a little bit repetitive, but just to emphasize how this goes into your CAS. So we've got converting 57.2 degrees into radians. So this time we want our answer to be in radians. It says 3 decimal places, so I'm going to change standard mode back into decimal mode. 57.2 degrees. Hit execute, and we get 0.99832. So rounded to 3 decimal places, that would be 0.998 radians. And especially because that number doesn't have pi in it, good idea to put the little radian symbol just to show that that's now a radian measurement. And last one is 2.75 radians into degrees. So we're going to change our calculator back into degrees mode, type in 2.75 radians, hit execute, we get 157.56. So to the nearest tenth of a degree, that's really just to 1 decimal place. So it will be 157.6 degrees. Right, hope that's making sense. Reach out and send me an email or a Teams message if you need a hand with any of these examples or the ones from the textbook. Have a good one.